Hello friends, welcome to our channel. In this lecture, I would like to explain another topic based on the steel tower design. So here select new and then give default file name will be steel tower or simple tower, any name. Okay, store your file in default location, then in the type choose analytical, units will be metric, and then create a new model. So you will get a default user interface like this, and again here in the geometry select grids option, and again in that beam grid option. See here the beam consists of 10 meters, means 10 right grids and 10 y direction grids. Okay, so this will be around 1 meter. For that you have to choose here edit option. See here right side 10 meters and in the y direction 10 meters, 1 meter spacing. So if I want to draw a 20 meters height tower, so for that I will increase my grids in y direction 20 meters. So I will increase 1 meter, otherwise I will keep 2, automatically you will get a 20 in that only. Then I will click OK here. So here now I will draw a tower in 2D and then I will modify into 3D. So see here I will draw like this, the inclined up to 2, from here 4 meters, 6, 10, 14, 18, 20. So like that I will take one tower shape. So this will be 2 meters and again the same 2 meters, 4, 4, 4 meters. I am roughly drawing the shape of the tower with some particular dimensions. Okay, then click escape here, and again in the grids you please select beam grid. So then your beam grid will be unhighlighted here, and then in the view select front view. So see here this is the shape in the 2D view. Then again in the geometry select add beam option, select the nodes. So I will give cross members here. And again horizontal members. So after giving horizontal members and cross members, then see the model in 3D view. So view 3D. So it will be like this. And again, so by using translational repeat command in the geometry, select translational repeat command, and in the z direction, so with the default spacing 2 meters through the link steps, mean if I give link steps means automatically the horizontal members will be collected. I will show that one also. Then select the structure in the geometry in the select option, and again by using geometry then select the entire structure and then click OK. See here z direction means again another frame along with the link steps you will get here. See here in the 3D view the default tower will be like this. So first I create the structure in the 2D and then the same member will be selected in the 3D view by using translational repeat command. Okay, then again in the view option you see here. So in the 3D view it will be like this, in the front view it will be like this, and again in the right view, so see here cross bracings. So this is one frame, left side this is another frame, only horizontal members will be collected, but here the width of the tower will be only 2 meters. Therefore, I am not assigning cross members. I am designing a simple tower. If I will give cross bracing means again it will get some extra time to assign properties to that particular bracings. Okay. If the width will be more than some 5 meters or 3 meters means at that time it automatically you have to give this cross members also. But I will choose in 2 meters only here. Then in the right view you can see same beam will be same frame will be appears here. Then our next step is keep the view in 2D. Then next step is assign the supports. So automatically assign the supports. So select supports and then here I will create the supports, and again in that fixed support add, and here select the support and then select by using nodes cursor nodes supports bottom side, and again check in the 3D view whether 4 nodes will be selected or not, and then assign this supports to the selected nodes. Same like as the previous examples, only drawing the frame and assigning steel properties will be different here. So your supports will be assigned. Then your next step is assigning properties and the two steel properties. In the previous lectures we designed RCC members like beam and frame. At that time in the define we can assign rectangular and square beam and column, but here you can choose directly section database here left to the define properties. By using steel designs select section database, so you will get a default user dialog box one more like this. I will show that one. See here the dialog box, this one section profile tables. In that by default it will be American, you choose Indian here. So after choosing the Indian, again there will be various shapes you will get. So generally for trusses and this type of simple towers we are giving angles only. So choose angles, and again so there will be some different vertical members, inclined members and horizontal members, cross members. So choose any 2 or 3 different materials for giving the number. For vertical and horizontal members, I will choose some heavy gauge Indian standard angles around some 150 by 150 by 15 add, and again for the horizontal members I will choose somewhat smaller than that number, which is 150 by 75 10. I will add close again, and again for another member I will choose some 100 side. If so I am just giving trial values, exactly I am not giving here. Then I will assign these 3 properties one by one. So I told you this higher value is only for the vertical members I will choose. So again here ISA. So here I will select first whatever possible terms directly. Select parallel to y axis. So whatever the members parallel to y axis selected, and I will assign that member to the y axis. Okay. And again I will apply the same property to the inclined members top and bottom. Okay. Here I will keep my structure in 2D view and I will select the members. I will select by using control option. So press control and then select. So automatically it will select what are the members you want, and again check in 3D view. See here whatever the members you want inclined it will be selected. So assign that property to the inclined members. Okay. Then in the again take this one and apply to the cross bracings. See here again keep you in front view and again using control option all the cross bracings, and again check in 3D view, see whether all cross bracings selected or not, and then assign that particular property to the cross bracings. Then and again select this third property and again directly select all parallel to the x-axis. So if you select x-axis, only x-axis cross horizontal members will be selected, and again select parallel to the Z axis. Then if you observe, entire horizontal and vertical members will horizontal in x and z directions will be selected. Then assign that property to the selected beams. So and then check in the 3D view whether all bracings are selected or not. Okay, see here entire frames will be selected. So generally we won't give horizontal member in the bottom. If you want you can keep, otherwise you can delete this one. So for deleting that one, directly you can go to the front view, sorry, side view, and then select the bottom one and then delete. And again in the right view select the bottom one and again delete. Okay, and again check in 3D and again 3D view. See here, this is the tower. Okay, so already we assign the property. Then our next step is loads, applying loads. Then in the loading tab select definitions. Why? Because already I told you, for towers in the open structure only we are building the towers like outside of the town. Then automatically we have to give that wind definitions also. Why? Because it will be 20 meters height tower. So if you choose on small towers like 5 meters or under 10 meters below, means no need to give wind definitions also. But for 20 meters and tall structures it will be high. So I will explain that also. In the definition select add, and again here in the wind, so wind 1. Okay, I will select 1, close, and again in the wind again I will add the heights. So here intensity for different heights. So I will take 1 unit kilo for kilonewton per meter square. Generally this intensity will be calculated by using some formulas in the steel code, that is kb into kt and again kc into vz. So it will be based on the topographical all the calculations. But here by in the STAAD you can assume some trial value and then directly you can assign it to the towers. But manually we are calculating all these things in the steel structural design, and it will be height of some 20 meters. Again this one intensity will be given up to some 10 meters, and again next for 15 meters I will give intensity of some 1.5 like that, and again next to 20 meters I will give some intensity of some 1.8 or 1.75 like that. I am giving some trial values, add, and again factor will be given default 1, add, close, assign this exposure to the entire structure. For that you can use assign to view command. Then as usually in the load case details click add, and again give primary one will be the dead load. So give the name if you want title as dead load, close, and again in the load case details. So there will be no any type of live loads acting on the towers. If you want you can give nodal loads only, but I am directly going for the wind load here. Wind load, I will give the name as wind load. So I told you while designing a truss how you can apply for the wind load nodal loads, like in the dead load click add. So giving the dead load which is self weight of the structure, which is factor 1, add, close, and again wind load you can give see here in the wind load. So you will get all these values highlighted because we already chosen wind definitions intensity. If you are not chosen here means it won't be highlighted. You please remember, you won't go directly for the wind loads. First you choose wind intensity and then come here. And again in the wind, so wind forces generally act in both x direction and z direction. If you want you can see how both will appear. For wind force in the x direction I will take so the range will be some up to 20 meters height. So generally from bottom to top I will keep 0 to 20 means bottom to top. For example I will keep some 10 to 20 different, and for different intensities you can choose here itself. Okay, x direction I will add here, and in the z direction again I will take one more value here. Again the wind load I will add, I will give this wind load in the open structure. So please in the edit option you please select open structure and then change here. If you see wind load will be selected like this in the x direction. If you see here only x direction blue with the blue lines will be highlighted. In the z direction it won't be highlighted. So for that, again in the wind load you can select windward face in the z direction only for 5 meters or some 10 meters, like that. Minimum range will be some 10 to 20 I will choose. So only top face only it will be highlighted. You will see the difference how it will be in the z direction. For again give open structure, add, change. See here, only top face, that is about 10 to 20 meters only highlighted in the z direction. If you choose this one, it will comes from bottom to top. Okay, entire face will be highlighted. If you want, you can see in the edit option 0 to 20 meters. Like that you have to apply wind definitions, wind load on a particular tower. Then again give the self weight of the structure, assign to view, means self weight will be assigned to the overall structure. So the wind load will be automatically assigned here. So here self weight and wind loads will be assigned like this. Okay, and then next option is your analysis will be completed. Click analysis, define the commands, print all, add, close, and again analysis, save the structure, check here. So it will be processing. So 0 errors and 0 warnings. Then you can go for the design purpose. So for design it will be very simple. Select here design, and again steel, because we are designing steel tower, steel, and then we are selecting parameter. First current code will be choose from IS. There will be IS 800, 800 and 207 LSD. I will choose this one, and again select the parameters. So here we will choose yield strength. So generally yield will be 250, that is Fe 410 for the steel, and RCC 415 and 500. So while explaining truss I will choose 415, but generally it will be taken for RCC. You just change the value Fe 410, means you can give yield strength as 250. I will select the parameter yield strength of the steel and then click OK. And you have to define this parameter. What I told the theory means, we can, so generally the yield will be around Fe 410 in the steel structures, but in the RC structures it will be 415 and 500. So for this yield strength will be 410 means, so we can take 410 into 1000 or 250 into 1000 for the steel structures. Click add and then close. And you have to define the commands. So what are the commands you have to define means, first you can check code and fix the group. So you see here what are the group things coming here, and then member take off, and then select, and then take off. So what are the things required for the design? So you have to assign all these commands. First yield, which is 25, 250, then assign to the view, means I will assign that yield to the entire structure. Then you have to check the code, assign to view, then still member take off, assign to view, select, assign to view, means I am assigning the things to the entire structure. Then still take off, assign to view. So after your analysis completed, then go for analysis, define commands, all, add, close, and then run analysis, save the structure. See here 0 errors and some warnings will be there. So for warnings no problem. Why? Because we are designing steel structures, maybe we will take some approximate values for trial and error purpose, and we are also giving I am explaining based on the wind load how it will be, like that I am showing in the trial version. So for warnings no need to worry, just check the errors whether the design is successfully completed or not. So here the design is completed. and then you can check in the post processing mode. You see the results. So check the axial force, annotate here, beam results, maximum. So see whatever the values you want. See here, we will check the values. If you want whatever the values you want, you can check force in y direction. So again in the z direction it will be different. So you check the results. Again select animation tab. See here, is there any deflection? See here, this is the how animation will be there in the x and y direction, it will be deflecting. And then in the analytical mode, check the steel design. So for that you click any particular member and then here choose steel design. See the numbers what we are assigned here, and again what are the property. So deflection, shear, bending, all the values on a beam. So if you want inclined members and any other horizontal members, you just go and check once and then see the steel design how it will be with the properties.
Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.